Another way that we can use the Pythagorean theorem is to prove whether or not, given the lengths of the sides of a triangle, is the triangle a right triangle. If it is a right triangle, then the Pythagorean theorem will hold true. A squared plus b squared will equal c squared. In this problem, we're given three different triangles and the lengths of the sides, and we're asked to see which of these are right triangles. So let's find out. Let's start with this one, number 1. Once again, I'm just going to write the formula once for all three. A squared plus b squared should equal c squared. If it does, then I know I've got a right triangle. And what I mean by that is 9 squared plus 12 squared equal to 15 squared? If it is, then this is a right triangle. Sorry, that A looks sort of like a 9. My apologies. All right. Actually, it's supposed to be a 9. That's why it did look like a 9. There you go. Teacher mistake. 9 squared, of course, is 81. 12 squared is 144. And 15 squared is 225. And does 81 plus 144 equal 225? It does. Therefore, I can conclude that a triangle with the lengths 9, 12, and 15 is in fact a right triangle. All right, let's try the second triangle if we can. I'm going to slide myself over here and up. This time I've got the lengths 10. I'm going to square that, plus 15. I'm going to square that, and that's supposed to equal 20 squared. And 10 squared, of course, is 100. 15 squared is 225. And 20 squared is 400. And as we can see, 325 does not equal 400. So a triangle that would have the lengths of 10, 15, and 20 is not a right triangle. All right, and so I'm going to do this last one, number 3, so right below it. Just draw a line here. And here we have 3.5 squared. This is this information I'm using, plus 12 squared. Does that equal 12.5 squared? Well, 3.5 squared is 12.25. 12 squared is 144. And 12.5 squared is 156.25. And if I add these two together, pardon me, I'm going to slide this over, I can see that this is in fact 156.25. It does equal 156.25, and I can conclude that a triangle with the lengths 3.5, 12, and 12.5 is in fact a right triangle. And here's another example of the same concept. We're given a triangle and its lengths, and we're asked, is this a right triangle? And even if it looks like one, we have to justify our answer. So let's see. A squared, and hopefully by now you're sick of seeing me write this and that you've memorized this formula. So is the square root of 45 squared, pardon me, plus the square root of 65 squared equal to 10 squared? And of course, the square root of 45 squared would be 45. And the square root of 65 squared would be 65. And 10 squared, of course, is 100. And as you can see, 45 plus 65 does not equal 100. I believe it equals 110. That does not equal 100. Therefore, we can conclude that this is not a right triangle.